Hi everyone, section 4.2, relations and functions. So in this section we're going to be working with what's called relations. And what a relation is a set of ordered pairs. Remember, your ordered pairs is your x comma y values. Relations can also be shown by tables, graphs, or mapping diagrams. So here's an example of a relation. It says showing multiple representations of relations. So here we have a relation with ordered pairs. We have 1, 5, 2, 3, 3, 2, and 4, 1. The first example is set up of a table of the relation. The second example is a graph. And the third example is showing a mapping diagram. So when we look at this, notice the table. The way this is set up is track meet scoring system. So when we look at this, the first value is representing the place in which they are in, and then the second value is representing the points. So for my table, for the place, that's representing my x. So notice my x values are 1, 2, 3, and 4. My points are representing my y values, 5, 3, 2, and 1. Remember, in ordered pairs, the first value represents x, the second value represents y. So this is representing the table. It says write all x values under the place and all the y values under your points. When we graph this, this is just like graphing points. Again, the place is representing your x values. X values on a graph go along your x-axis. And your points, representing your y, go along your y-axis. So when we graph, like for instance 1, 5, remember we always graph x first, so we go starting at 0. You always start at the origin, 0, 0, so 0. We move 1 place to the right, and we go up to 5 spots and put our dot. The second is 2, 3, so starting at 0, we move to the right 2, go up 3, and put our second dot. Third point, 3, 2, move over 3 places to the right, go up 2. And last one, 4, 1, move to the right 4, go up 1. So it says use the x and y values to plot the ordered points. So that's how we would do this graphing. The third representation of a relation is by the mapping diagram. Notice my place, my x values are on the left. My points, the y values, are on the right. Notice for every place that goes to the point. So 1 goes with 5, 2 with 3, 3 with 2, 4 with 1. So you write all the x values under the place and all the y values under the points. You then draw an arrow from each x value to its corresponding y value. So hopefully this makes sense of how the relations can be shown by tables, graphs, or mapping diagrams. Here are some more definitions we're going to see working with relations. Sometimes they'll ask for the domain of a relation, and the domain is the first coordinates or the x values of your ordered pair. So for instance, if I had 1, 5, 2, 3, my domain values would be 1 and 2, because those are representing my x values. The range of a relationship is the second coordinate or your y value of the ordered. So your y value of your ordered pairs. So when you look at these two examples I gave up here, my range is going to represent 5 and 3. Now, when you're working on questions out of the book for this section, they're going to ask you if the relation is a function or not. So a function is a special type of relation that pairs, sorry, that's a typo, that pairs each domain value with exactly one range value. This is very important. So your domain value is paired exactly with one range value. And so I'm going to show you some examples of this. So here we have a relation. We have 1, 3, 2, 4, and 3, 5. They want us to give the domain values. When you're writing the domain and the range values, they do need to be in the parentheses. So these up here need to be in parentheses. Here we have the values in parentheses. Remember, the domain values are representing your x values. So my x values are going to be 1, 2, and 3. Now we need to look at our range values. Again, the range values are representing the y values with an ordered pair. So my range would be 3, 4, and 5. So here we have a range value, 3, 4, and 5. Now look at this. We have one x value to one y value. This example here would be a function. If this doesn't make sense, we'll go on and do a few more examples here, working with relations, naming the domain and range, and determining if it's a function or not. So here we have an example. Express the relation 2, 3, 4, 7, 6, 8 as a table, a graph, and a mapping diagram. This is similar to one of the first slides where I showed you the 3 different representations of a relation. Remember, when you have your ordered pairs in a relation, the first value is representing your x, second value is representing your y. So when I express this, here we have our table. The x value goes first in the table, then the y value. 2 and 3 is the first one. 4 and 7 the second. 6 and 8 the third. We have our mapping diagram. So you have your x's on the left. You have your y's on the right. 2 to 3, 4 to 7, 6 to 8. The last one is our graph. Remember, your x values go along the horizontal axis, your y values go along the vertical axis. Now, looking at this, my x and my y, for each x, is it placed with the y? Yes, so it's not asking us this in the question, but it would say, is this relation a function? And the answer to this is yes, because for each x value, it is paired with one y value. The next example, they want us to give the domain and the range of this relation below. Notice this is representing in a graph form. The domain is your x, range is your y values. So when we look at our x values, when we're looking at the domain, we'll look along the horizontal axis first. So what domain is it going along the x value? You're going from 1 to 5. For our range values, looking at the y values, you're going from 3 to 4. So the domain, the answer to this, the domain, here's the answer, the domain is the range from 1, which is less than or equal to x, which is less than or equal to 5. The answer for the range, 3 is less than or equal to y, y is less than or equal to 4. Notice how they wrote for the graph, the domain, and the range as an inequality situation right here. So I do expect you to do that when you see a graph. Determining the domain and range is setting it up like inequality, the range in which it falls. or the values, I should say, in which it falls. Here we have another example. Now this is very similar to what we've been doing, but notice it says give the domain and range, so we've been working with this, of each relation. Tell whether, here we go, tell whether the relation is a function and explain, okay? So when we look at the first table, this is representing field trips, X is representing your students, Y is representing the number of buses you need. So for 75 students, you need 2 buses. 68 students, you need 2 buses. And 125 students, you'll need 3 buses. So how can I write the domain and range of this? Well, here we go. The domain, we write our X values, right? My X values are 75, 68, and 125. Write them in that order. They do need to be in the parenthesis brackets. And then my range are my Y values. So when I look at my Y values, I have 2. You don't need to write 2 twice. Since you have 2 twice, just write it once. 2 and 3. So here's my domain and range. Now, for each X, is it paired with one Y? Yes, it is. So for this situation, this relation is a function. Each domain value is paired with exactly one range value. So that is an example there with the table. Let's look at the mapping diagram. Notice we have our X's representing on the left, Y's on the right. X's are 7, 9, 12, 15. Y's are -7, -3, and 0. Notice with this mapping diagram, 7 is going to -1 and to 0. That means that X value is not paired with one range value. So in this situation, it is not a function. But before I jump ahead and write that it's not a function, let's write the domain and range values for this. So the domains, again, X is 7, 9, 12, 15. We'll write that in the brackets, 7, 9, 12, 15. The range is -7, -1, and 0. Here we have -7, -1, and 0. Notice they're not in numerical order. They're in order based on how they're shown on the mapping diagram or on the table. And when I determine if this is a function or not, remember we said no, this is not, because 7 is paired with 2 Y values, -1 and 0. So this relation is not a function. Each domain value does not have exactly one range value. The domain value 7 is paired with the range values of -1 and 0. So that makes it not a function. All right, so these are the types of questions you're going to see in the bookwork in section 4.2, and you might see some questions like this on your quiz Wednesday.